Hello, my name is Edwin van Hoven. We are here at the EMC test facilities of Dare Measurements with John DeRoy, the software developer of the RadiMation EMC test software. John, can you give a brief introduction about the RadiMation EMC test software?
Yeah, of course, Edwin, I can. We started the development of RadiMation in 1995 with the goal to create a very user-friendly, powerful, compact and modular EMC software package to automate EMC measurements. Nowadays, it's used by several hundreds of companies worldwide in different business areas like automotive, commercial, telecom, military and medical laboratories.
So that's quite an achievement, John. Can you tell me what we're going to see now?
I'm going to show you how we are using the Dare Instruments RadiField Tripple A field generator to perform a 16-point uniform field area calculation inside RadiMation from the frequency range of 1 GHz to 3 GHz.
Okay, John, can you tell me which equipment are we going to use for this calibration?
We're going to use the RadiCentre, and this RadiCentre contains the RadiField, the RadiGen and the RadiSense plug-in cards.
So if I understand correctly, all instruments that are needed for the uniform field area calibration are integrated into one single RadiCentre unit.
Yes, that's correct. And this RadiCentre is connected to the RadiMation software on the PC by a single communication interface.
Okay, clear. But can you show me what's inside the anechoic chamber?
Yes, I can show you how the setup is done inside the anechoic chamber. Here you see the RadiField Tripple A field generator. It's positioned at 3 meters distance from the RadiSense field probe, which is in the calibration jig. The calibration jig is 1.5 by 1.5 meter and exactly specifies the 16 positions that should be measured. These 16 positions are exactly as described in the IEC 61000-4-3.
Okay, John, that's clear. But can you show me how the instruments are being controlled from RadiMation?
Yes, but then we have to go outside.
Okay.
So first I'm going to show you how to start RadiMation and how to configure all the measurement equipment inside the configuration of RadiMation that are also in the RadiCentre. So in RadiMation we first have to go to configuration and then to the device drivers, and then we can go to amplifiers, and then we can add new device drivers, for example the RadiField. Here we can select the RadiField device driver and then it will be created. The configuration can be further configured communications by clicking on the advanced button, and then specific communication channels can be configured, especially the multi-slot RadiCentre and the device identifier inside the RadiCentre can be selected. Also for the field sensor we can add the RadiSense, which is inside the RadiCentre. We can press on advanced. We can select the communication method, for example TCP/IP, and we can configure on which slot it is configured inside the RadiCentre.
So now all instruments are configured. What is the next step?
Now we have to create a test site inside RadiMation. For example, we can call it RadiField, and then we have to select all the devices that are configured inside this list. And I can just select all the different power meters, signal generators and so on. Now all the equipment is configured in the test site. We can very easily start a one-point system calibration. I can just select this pre-configured TSF and we can see that the test is running from 1 GHz to 3 GHz with 1% step for 18 volts per meter.
Okay, that's clear. So now we can do the first calibration. Can you show me how that works in RadiMation?
Yeah, I already loaded the configuration of the calibration. I can just press run calibration and then RadiMation will check if all equipment is connected and if it's available and turn on. We even do a power delivery test to ensure that the amplifier is activated. And when the power delivery test is successful, RadiMation automatically continues with the real calibration.
Okay. John, during the calibration, can you show me some graphs?
Yes, during the calibration we can already review all the information. We can, for example, show the graph of the forward power that's being generated, but also the signal power is available. And of course, we can show the field graph of the field that's being generated. And we even can zoom in on the graph to have a very high detail. So now the calibration is finished, and now we can save the test data into a calibration file. I just use the proposed name. I additionally say point 1 because this is the first point, and I click save.
And this now has to be done 16 times for all 16 positions.
Yes, that's correct. This has to be repeated 16 times.
So now the first calibration point is ready. Before we go to the second calibration point, we first have to position the probe to the next position.
Yes, that's correct. We first have to reposition the probe. And now we have moved the probe to the second position. We can very easily start the same calibration again by selecting the same test setup file, press run calibration, and now the calibration is running again.
Okay, so now all 16 points have been calibrated. Can you show me how the uniform field area calculation method works?
For the uniform field area calculation, we can select calibration menu again and then select the uniform field area calculation option. We just create a new configuration, and now we can very easily add all the 16 individual calibration files. I will perform a relayout on the 4x4 grid, so now they are nicely laid out in the 4x4 grid. And then here we can also select the calibration method, that calculation method that should be used. For now we just select the EN 61000-4-3 for the 2010 version. We press calculate. I don't want to store this configuration, and then the calculation is finished.
Okay, John, so the 16-point uniform field calculation is ready. Can you show me how the results can be presented in RadiMation?
Now all the results are just available from this result screen. So we can just click on the graph, and then we see the graph. We can click on the forward power graph, and then we see the calculated forward power that's required for all 16 points. Also, it's possible to show the overall error graph, which shows the overall error after calculation. And it's even possible to click on one of the dots inside the graphical representation, and then we see the data of that specific point in the 16 points.
Okay, so looking at the overall error graph, I see that the RadiField is well within the 0 to 6 dB limits, which is required in the standard.
Yeah, that's correct. The RadiField is below the 6 dB limit.
Okay, John, thank you for this clear demonstration. If you want to have more information on the RadiField or RadiMation EMC test software, go to our website www.dare.eu. Thank you.